Okay, we're looking at question number 3 here. Gives us a balanced equation. Part A says if propane reacts with oxygen as above, what is the limiting reagent in a mixture containing 5 grams of C3H8 and 10 grams of O2? All right, there is more than one way to solve a limiting reagent problem. So typically when I look at this, I'm thinking of a two-part type question, and I want to look at what B asked for and see if it's a follow-up to this. Because had it asked in part B, what's the total yield of CO2 using either the 10 or 5, we would do two different equations. One where we're going to take that 5 grams of C3H8 and one where we're going to take 10 grams of C3H8. And what we would do, or 10 grams of O2, sorry. And what we do is convert both of these into a mass of CO2. But part B doesn't ask anything about that. It asks if C3H8 reacts completely. So up here, since this A is its own standalone thing, I'm only going to do one of these, because what I'm going to do is figure out the amount of O2 is needed to use up all 5 grams of C3H8. So I'm going to need to get the molecular weight of C3H8, so I can convert that into moles. I'm going to use my balanced equation to show you that there is 1 C3H8 for every 5 O2s. So we're just relating our two reactants in this case. And then the last thing we're going to do is convert the moles of O2 back into grams. All right, that one, 32.00 grams. And to calculate the C3H8, we have 12.01 times 3. Oops, I didn't do it times 3. And then we'll add 8 times 1.008. I didn't do the 8. And I get molecular weight of 44.09. Alright, now if I do this conversion as I've just written it down, so 5 divided by that 44.09, then multiplied by 5 divided by 1, and then multiplied by 32, we get that for this to totally react, we would need 18 grams of O2. I'll do 18.1 grams of O2. Alright, now that's telling us to use up all 5 grams, we would need 18 grams. Well, we only have 10 grams of O2. So before we've used up all 5 grams, we're going to run out of oxygen. So oxygen is our limiting reagent in this case. Now, if, for instance, it asks for the actual yield of, like, CO2 produced, we would actually have to use the 10 grams of oxygen to calculate that, because it is our limiting reagent. But in this case, it didn't ever even do anything with the 10 grams, because it only asked me to calculate the limiting reagent. Alright, on B, wants us to know the mass of CO2 formed if 1 gram of C3H8 reacts completely. Now, by saying reacts completely, they're saying we're assuming there's plenty of O2 in this case. So we're going to start with just the 1.0 gram of C3H8. And this setup is going to look very similar to what we have in A, in the sense that we're going to turn that into moles first of all. And similar to A, we're also going to have a stoichiometric conversion factor. But instead of having O2 on top, since this was asking about CO2, we're going to put the CO2 on top. And we're getting these two are what we're relating now. And then our last conversion, 1 mole of CO2 is, let's see, 16 plus 16 plus 12.01, 44.01 grams. And therefore my answer in this case is going to be 1 divided by 44.09 times 3 times 44.01. And I get 2.99 grams.